Good afternoon. We're here at the Bandaranaike Memorial International Conference Hall to participate in the Arthur C Clarke Lecture and Awards ceremony. The recipient of the 1987 Arthur C Clarke Award for outstanding contributions in the field of communication technologies is one of the most distinguished scientists and engineers of the United States, Dr. John Robinson Pierce. The significance of the event is that it is also today Dr. Arthur C Clarke's 70th birthday, and for the second year, the award and lecture is being held on the same day. The Arthur C Clarke Center for Modern Technologies has been entrusted with the responsibility of accelerating the introduction of computers, communication, space technology, robotics, and energy for the development of this country. Dr. Pierce is being presented with the 1987 Arthur C Clarke Award for his pioneering work in the field of communications. He has for long been associated with the frontiers of electronic technology. His work on the theory of communication satellites led to the experiments that facilitated the development of Telstar, which marked the beginning of efficient worldwide radio and television communications. Developing countries in particular have greatly benefited from these advances in communications technology. As Executive Director of the Research of Communication Sciences Division of the Bell Laboratories in the United States for 35 years, Dr. Pierce was in charge of work on mathematics and statistics, speech and hearing, behavioral sciences, electronics, and radio and guided waves. Dr. Pierce was instrumental in the launching of Echo 1 satellite in 1960. At the California Institute of Technology, where he was professor of engineering, he was concerned with energy consumption in personal transportation, satellite systems, and auditory perception, to name but a few areas. At present, at Stanford University, he is involved with various aspects of musical, sound, and perception. Dr. Pierce, who has his BS, MS, and PhD from the California Institute of Technology, also has 10 honorary degrees to his name. He is the author of 17 books on communications, sound waves, electronics, and other associated subjects. This event here today is being transmitted live to the United States. We are establishing a link with Washington via Paris using 2 satellites, the Indian Ocean Intelsat and the Atlantic Ocean Intelsat. In a few moments from now, we expect the chief guests to arrive to participate in the ceremony. The chief guests, if I may begin to tell you now, are of course His Excellency the President, Dr. Arthur C Clarke, Dr. Stanley Kalpagay, Professor Willie Mendis, and of course Dr. Pierce. I think it's worth noting that, as I said earlier, today is the 70th birthday of Dr. Arthur C Clarke, and I'm sure we all join in to wish him continued health, happiness, and success. As you can see, the guests are awaiting the arrival of the chief guests. I'm sure you can pick out many familiar faces in the audience. People connected with the world of science, communications, and other associated fields. After the award and lecture part of the ceremony, there will be a live teleconference with Washington. The panelists will include the names I mentioned, the chief guests, and a panel of scientific people in Washington. I'm sure many of you watching this live telecast will have glanced through today's papers, all of which carried articles not only on Dr. Arthur C Clarke himself and his illustrious career, but also on this event itself, the presentation of the Arthur C Clarke Award and the lecture, which is to be given by Dr. John Robinson Pierce. This event, may I remind you, is being transmitted live to the United States through WorldNet, which is the United States Information Agency's global television network. We are, as I said, waiting for the arrival of the chief guests. Well, I can hear the sound of the drums, which indicates that the guests have arrived, and they will shortly be entering this hall here. As you know, the BMICH is rather a vast place, so it does take a certain amount of time for the procession to get into the hall. And there you have it, the procession is arriving into the lobby area. And there you see the chief guests being garlanded. His Excellency the President of the Socialist Democratic Republic of Sri Lanka, Mr. J.R. Jayawardena, the chief guest on this occasion. Dr. Arthur C Clarke, Chancellor of the University of Moratuwa and patron of the Arthur C Clarke Center for Modern Technologies. Dr. Stanley Kalpagay, Secretary to the Ministry of Higher Education, Chairman of the University Grants Commission and Chairman of the Board of Governors for the Arthur C Clarke Center for Modern Technologies, and Professor Willie Mendis, Vice Chancellor, University of Moratuwa, Vice Chairman and Director of the Arthur C Clarke Center, and of course, the recipient of the award this year, Dr. John Robinson Pierce. Our cameras follow them as they are being led into the main hall.
We will begin the proceedings in the customary manner by lighting the traditional oil lamp. I wish to request His Excellency the President and the distinguished invitees on the head table to light the traditional oil lamp. I will now request the Chairman of the Board of Governors of the Arthur C Clarke Center for Modern Technologies, Dr. Stanley Kalpage, to deliver the welcome address.
Your Excellency, the President of Sri Lanka, Professor Willie Mendis, Director of the Arthur C Clarke Center for Modern Technologies, Dr. Arthur C Clarke, patron of our center, Professor John Robinson Pierce, recipient of the Arthur C Clarke Award for 1987, distinguished guests, ladies and gentlemen. As Chairman of the Board of Governors of the Arthur C Clarke Center, I should like to welcome all of you to the second Arthur C Clarke lecture and presentation of the Arthur C Clarke Award. Your Excellency's keen interest and unflagging enthusiasm was instrumental in the setting up in 1984 of the Arthur C Clarke Center for Modern Technologies. This is yet another of the institutions set up by this government designed to enable Sri Lanka to keep abreast of the rapid developments in science and technology. The Arthur C Clarke Center works in close cooperation with the University of Moratuwa and is statutorily mandated to conduct research, training, and dissemination of knowledge in 5 areas: communications, computers, space, energy, and robotics. The center has now got moving, and there are projects in place on communications, computers, and remote sensing. This year's Arthur C Clarke Award for outstanding contributions in the field of communications technology goes to Dr. John R. Pierce, Emeritus Professor of Engineering, California Institute of Technology, and former Executive Director, Communications Division, Bell Telephone Laboratories. Dr. Pierce will deliver this year's Arthur C. Clarke Lecture. We are glad that Dr. and Mrs. Pierce have found it possible to be with us on this occasion. We wish them an enjoyable stay in Sri Lanka. Dr. Arthur C. Clarke will be celebrating his 70th birthday anniversary today. We in the center are honored and privileged to have him as our patron. His presence at meetings of the Board of Governors inspires us. We will be celebrating Dr. Clarke's birthday by cutting a cake at the reception later this evening, when a felicitation volume will be presented to him. I should like to wish Dr. Clarke many happy returns of the day. Your Excellency, ladies and gentlemen, I thank you for your presence and I welcome you. Thank you.
It is my great pleasure now to ask His Excellency the President to deliver his address.
Dr. Clarke, Mr. Kalpage, Professor Pierce, Mr. Wells Mendes, Your Excellencies, Honorable Ministers, ladies and gentlemen, this is a very unique occasion. It may not rise again in our lifetime. We are not only celebrating the birthday, 70th birthday of Mr. Arthur C. Clarke, but we are celebrating the birthday, if I may say so, of one of the creators of the technological age. It is similar to the United Kingdom at the beginning of the 19th century, when James Watt discovered the use of steam, and he inaugurated the whole world of the Industrial Revolution. The use of steam, the use of electricity, the use of petrol and its allied other means of energy. And the world that we know as today, before Mr. Arthur Clarke wrote his magic words in 1945, is being changed gradually, sensibly, humanely, but definitely. If I may call it, to the age of technology. There may be other words that you could use, but the word technology covers the entire world as we know it, universe, far away into space, not only as far as I can see, but as far as the human mind can judge. It is Arthur C. Clarke's words that went throughout the world and gave rise not only to technological communication, but also to other means of human endeavor, such as the use of computers, microchips, large number of other inventions. We are proud that Arthur C. Clarke is a citizen of Sri Lanka. We are privileged that he should be one of us, and we are honored that we are able to do him some honor in our own country. Today, when I came here, I was greeted by drummers and dancers. They represent the medieval aspect of Sri Lanka. we come to the hall and discuss very modern concepts, going even beyond what we know of in the world today. And we owe a lot of it to Mr. Arthur C Clarke. I've known him for a long time, long before I was president, when I was, I think, in the opposition. But he and I have treated each other exactly alike, as two friends. I'm happy to be able, as president of this country, to give him this honor, this privilege, and this welcome. As a citizen of Sri Lanka, Arthur C Clarke, we bend our heads to you in tribute. May I therefore inaugurate the sessions today of the Arthur C Clarke Center, founded by this government in 1984, as Dr. Kalpege explained, to do many things. We are only starting our work, but in the years to come, we hope they will not only cover Sri Lanka, not only the world, but we have our program to cover the whole of space. It may be ambitious, but the human mind, in its ambition, reaches far beyond what we can see and what we can hear. Thank you, Mr. Clarke, and thank all of you for attending this function. Thank you.
Your Excellency, President of the Democratic Socialist Republic of Sri Lanka, Honorable Ministers, Honorable Deputy Minister, Your Excellencies, Dr. Stanley Kalpege, Dr. Arthur C Clarke, distinguished invitees, ladies and gentlemen. It is my great pleasure to introduce the distinguished recipient of the 1987 Arthur C Clarke Award, Dr. John Robinson Pearce. Dr. Pearce is a communications engineer and scientist. After completion of his doctoral studies at Caltech, he began working for Bell Telephone Laboratories in New York City. There he improved the traveling wave tube, which is used as a broadband amplifier of microwaves, and designed a new electrostatically focused electron multiplier tube used as a sensitive radiation detector. His Pearce electron gun produces high-density electron beams. Dr. Pearce was also associated with the development of the low-voltage reflex klystron oscillator that was almost universally used in US radar receivers. In 1952, Dr. Pearce became Director of Electronics Research at the New Jersey Division of Bell Laboratories at Murray Hill. 2 years later, he began work on the theory of communication satellites. He wrote numerous papers detailing the advantages of using satellites to relay radio communications to all parts of the Earth. Seeing the opportunity offered by the Echo balloon satellite for studying space phenomena, he persuaded NASA to convert the 100-foot aluminized sphere into a radio wave reflector. Echo 1 was launched on August 12, 1960. The success of the communications experiments carried out with Echo 1 provided the impetus to develop Telstar, a satellite designed to amplify signals from one Earth station and relay the signals back to another Earth station. These early satellites marked the beginning of efficient worldwide radio and television communication. Dr. Pearce retired from Bell Laboratories in 1971 and became Professor of Engineering at the California Institute of Technology, Caltech, at Pasadena. 6 years ago, he was named Chief Technologist at the Jet Propulsion Laboratories in Pasadena. Presently, he is visiting Professor of Music at Stanford University's Center for Computer Research. Dr. Pearce has written many books on electronics, satellite communications, and information technology. He holds membership in several famous professional and scientific bodies, including the National Academy of Engineering and National Academy of Sciences. Dr. Pierce has also been honored on many occasions and was the recipient of the prestigious Japan Prize in 1985. The dedication of Dr. Pierce to contribute to the development of communication satellite technology has enabled countries like Sri Lanka to access the vast potentials of global communications. The benefits have been enormous for the development of these nations. Your Excellency, in recognition of this dedicated and outstanding contribution to communication technologies, the Board of Governors of the Arthur C Clarke Center for Modern Technologies unanimously resolved that the 1987 Arthur C Clarke Award be made to Dr. John Robinson Pierce. It is with much pleasure that I wish to request Your Excellency to present the award to Dr. John Robinson Pierce. I wish now to request Dr. John Robinson Pierce to deliver the 1987 Arthur C. Clarke lecture.
Your Excellency, Excellencies, distinguished guests, it's hard to know what to say in this wonderful country and on this wonderful occasion in the presence of the President of Sri Lanka, in the presence of Arthur C. Clarke on his 70th birthday. I've known Dr. Clarke for many, many years, and my admiration for him is unbounded. Arthur Clarke has commented on the technological challenges and the problems that face the world. He's conjectured wisely on what may lie in our future. And that is what I myself shall talk about, though I cannot promise you wisdom. For 35 years, I worked at Bell Telephone Laboratories, which in past days designed all American telephone equipment and did most of our research on telecommunications. The division I led included at one time or another, work on vacuum tubes, on microwave radio, on guided waves, including optical fibers, on switching, on mathematics and statistics, behavioral research, including experimental psychology and speech and hearing, and economics. I became involved in all of these subjects to a greater or lesser degree. Though my chief interests have changed, I try to keep in touch with many of the things that I followed then. Today, as you've heard, I'm at the Stanford Center for Computer Research in Music and Acoustics, referred to as CARMA, CCRMA, and pronounced by us Karma, and it's indeed been my happy destiny. My presence there is no accident. In 1957, a colleague of mine at Bell Laboratories first used the computer to produce musical sounds. I'm still associated with him. He's now at Stanford, and the Center for Computer Research in Acoustics and Music is, I have every reason to believe, the outstanding center among many hundreds in the world. While computer music is the thing I've been most directly associated with in recent years, it's not the thing that I'm going to talk about tonight. Tonight I'm going to talk about computers and about space and about communication. Today, computers are the most complex of all the things that men have made. I often think back to the days of science fiction when people wrote stories about robots or androids, mechanical men or electronic men or biological mock men. Well, this thought has not entirely vanished. People who pursue a field called artificial intelligence are busy year after year in trying to make computers into imitation men, and in trying to make computers do things at which they aren't very good. Now, computers aren't inferior to people, and I think that this is a rather put down of computers by the AI researchers in trying to make them display their deficiencies in doing what men do better. Really, computers were much superior to men from the very earliest days, and that is why they were made. They will add and subtract and multiply and divide much faster than people can, and without the inadvertent errors that people make. And even in more advanced mathematical manipulations, manipulations at which people almost always make errors, computers don't make mistakes. Moreover, beyond this, people have programmed computers, have produced computer code that incorporates our knowledge of the world, our knowledge of science and engineering, but also incorporates algorithms for solving problems. And at solving problems in certain ranges of our life and activity, computers are far outsell what we can do with just pencil and paper. Moreover, computers are good at producing graphical images of things, at designing machines, and not only at producing the graphical images, but at working out analyzing the technical details, so that you end up not with just numbers, but with a prescription for making computer-controlled machines actually produce things. And this is called CAD-CAM, computer-aided design and manufacture, and it's a real thing. Not everything is manufactured, not everything is designed with computers, not everything is manufactured according to computer instructions, but more and more things are designed and manufactured this way. So there have been two dreams of complicated machines. One in early science fiction, and not in much of the science fiction of Arthur Clarke, who knows better, of making machines imitate men. And another tradition that has grown up, the actual tradition of making machines superior to man in their limited way, making machines that will help man by doing things for him much faster than he could do them himself. I sometimes think that the idea of just imitating men would be like the idea of making an airplane that would imitate a sparrow and insisting that it land on a twig. Well, jet airplanes don't land on twigs, and they don't do all the things that a sparrow can, but they are much more useful to men than sparrows are. I think this should give us pause. The picture of mechanical men that we inherited from early days, and the picture of a computer that is in a limited way very much superior to man and is our tool. It seems to me that our experience in space has been somewhat similar. The early science fiction writers, and I won't accuse Arthur Clarke of this because he's innocent, wrote about a sort of cowboys and Indians conquest of space, or a reenactment of Columbus, in which we would do again all the old things that we did in conquering the Indies, for instance, but do them someplace else. Well, we did some of those wonderful dreams. The Apollo program that landed men on moon and brought them back was a magnificent realization of an early dream of space, and it was very valuable. It showed what we could do. It also showed some of the difficulties in sending men into space. The difficulty, the cost of providing him with oxygen and with food and taking care of his wastes. We've gone beyond Apollo, and men have been in space longer, and other things have appeared. Nausea, the changes in the function of the heart, weakening of the bones, many problems that hadn't been anticipated in the early days, in early dreams of manned spaceflight. And spaceflight has come. It's come partly in the way that we expected, but partly not. Now, in his writings, Arthur Clarke said at one point that perhaps spaceflight, it had certainly come before he had expected it. Perhaps in some ways it had come too soon, before all the problems that we need to solve in putting people economically onto the moon and onto the planets had really found their solutions. But one can look at this in another way. Spaceflight came at about the same time that efficient computers came. In an earlier day, it would have been impossible to carry out complicated missions such as the voyage of discoverer of Voyager to not only Jupiter and Saturn, but Uranus and eventually to Neptune. It would have been impossible to have such extended voyages without man there to care for the instruments and to repair things. But now we have a complicated solid-state technology, and really many things that we launch into space become obsolete before they wear out. As I said, Voyager, we expect to go to Uranus. Well, it has gone to Uranus. We expect it to go to Neptune. The mission that we sent to Mars, Mariner, the landers function for a long period, and the orbiters function for about 5 years, the best orbiter. In fact, the trouble with the orbiter was that the ground personnel were cut down so much after the lander activity, the major lander activity, that they couldn't watch over the orbiters. Originally, the orbiters were controlled entirely from Earth on the basis of data sent back. Well, this just didn't work. And in the course of the Viking mission, the situation was investigated from Earth. It was found that the sensor data that ordinarily went to Earth could be turned over to the onboard computers. And in essence, the first robot ever manufactured in space was constructed. The men no longer took the information from the sensors and told the orbiters what to do. The orbiter's onboard computer took the information from the sensor and automatically controlled the charging of the batteries, the loss of star tracking, and the recovery from that, the changing from star tracking to inertial navigation, turning off things during eclipses of the orbiter so that the batteries would not become exhausted. And the orbiter worked very much better as a robot built in space than it did as a tool of man controlled from Earth. So the course of our exploration of space has gone partly according to earlier prognostications, but partly it has benefited from this very powerful computer technology that we have used in Earth and that we use in space. And I would say here that the unexpected is the course of technology. We can plan, we can look forward, but we won't know what happens until we have actual experience, the sort of experience that is being sought at the Arthur C Clarke Center. My own experience with space was really unexpected. After World War II, because I had written science fiction, I gave some talks on space. But they were drawn from science fiction rather than from reality. And in 1954, I was asked to talk to the Princeton section of the Institution of Radio Engineers, which has since changed its name. And I thought that my early space talks weren't quite the right thing, so I decided to talk about satellite communication, which I did not regard as a new idea, and indeed later I found out it wasn't a new idea. Arthur Clarke had written about it in 1945. I was thinking of unmanned satellites rather than space stations. And I gave the talk, and it was published in 1955, but there I was stuck because there was no way of putting up satellites. Well, Sputnik was launched in late 1957. Somebody asked me how that seemed to me, and because I had written science fiction, I thought of a sort of parable. I said that Sputnik struck me as it would strike a writer of mystery stories if he went home and found a corpse in his living room. Well, I was very glad, however, that Sputnik had been launched. Soon there were American satellites, and I wondered if we couldn't do something about satellite communication. As was recounted earlier, we found that there was indeed a balloon-type satellite, the same thing I had envisioned as a simple communication satellite that NASA had, and by a process of help and persuasion from a number of people, it was launched and became ECHO and transmitted a presidential message, voice message, from one coast to the other. That created great enthusiasm, partly, I think, because ECHO was a bright star in the sky and attracted attention just as a spectacle. Anyway, it attracted the attention of the management of the AT&T, American Telephone and Telegraph Company, and AT&T built and launched Telstar at its own expense. And Telstar was another step forward because it transmitted live television across the ocean. And after that, there was no doubting the feasibility of satellite communication. The only question was the form, and synchronous satellites, which Arthur Clarke had envisioned, followed in 1953, and in 1955, commercial satellite service. This went much faster than I had expected, just as Arthur Clarke found the conquest of space exceeded in speed what he had expected. So satellite communication, the application, exceeded in speed what I had expected. And this was very gratifying. And from there, we have gone to all sorts of wonderful things that I shan't talk about. One thing that I shall mention is that part of making the world into a global village, which Arthur Clarke rightly says satellites have helped to do, is transportation as well as communication. one can't make a global village entirely just with communication satellites. One needs people to meet one another face to face. And this air transport has done better than ships ever could, because it's not only cheaper, it's faster. People who don't have much time to spare can now visit far lands. But air transport can't work without communication, and here we have an example of data banks and data storage in the running of the airline, something that Arthur Clarke has envisaged. And air transport can't run without keeping track of the airplanes. Currently, this is done by radar on the ground. But a fellow I know has pointed out that when the Global Positioning System, or NavStar, is fully implemented, one can keep track of all the aircraft even more accurately than one does by radar. All this information can be available on the individual aircraft, and the ground control terminals need only interrogate airplanes to find out where they are. Whether this will come into being, I don't know. Sometimes people in government services are very slow to latch on to new things, but it may very well. And other things will come into being, and have come into being. The following of weather by satellites, the observation of the Earth by satellites. Already, with the global positioning satellites they have, my land can be surveyed more accurately by the GPS or NavStar system than it can by traditional means of surveying. It can be surveyed to within a fraction of an inch, I believe, if one is careful enough. And I'm sure that this can be done as the system is deployed for other countries than mine. Indeed, the idea has been that the GPS system will be of general service to all nations when it is completed. There is just no end to the things that can be done by a combination of computers and space and communication. I haven't mentioned a great deal of it. And there is no end to what can be done in space. Some people are a little disappointed that the manned exploration of space hasn't gone further. Technology will make it more feasible and more economical than it is at the moment. Space is an endless frontier. There's space enough for all, for unmanned exploration, and for manned exploration. I'm very lucky to be here and to have this borne upon me through the work that is going on in all the world, and indeed in Sri Lanka. Thank you.
Thank you very much, Dr. Pierce. We are now about to start the teleconference with Washington. The procedure would be the panel here would proceed to the next room, which is committee room A, and I would kindly request all of you in this committee room to stay. The two wide screens that you see right here will display to you all what is going on between us in Colombo and our counterparts in Washington. Immediately after the teleconference is a reception which is just outside, and those whose invitations to the presidential suite have been given, the ushers will escort you to that. But after the teleconference is over, may I kindly request you to be in the seats till we proceed. Thank you very much.
Well, that brings to a close the Arthur C Clarke Award and Lecture Ceremony. As you just heard, in a few moments we will be joined